Hello, the subject of this lesson is gradient and proportionality. What is rate? Rate shows us how fast one quantity changes as the other quantity changes. So basically, we're talking about two quantities which are related and we are comparing them to each other. And the second quantity has to be expressed in 1 unit. Let's see if we can do an example on that. For example, when a tank is being emptied, we might say the rate of water being emptied is 10 liters per second. So 10 liters per second. So here we are talking about two quantities. One is the volume of water, which is 10 liters or given in liters. And the other one is the time, which is in seconds. As you can see, second has no number, means 1 second. All right, so then we write it 10 liters per second. That's what it is. So liter is 10, but second is just 1. So means for each second we have 10 liters of water being emptied. All right, for this example, a car travels 320 kilometers in 4 hours. What is the rate of distance with respect to time? So the way we go about it is we say, all right, we're talking about two quantities. I write the quantities at the top. What are the quantities we're talking about? One is distance, how far the car travels. The other one is time. I'm going to write all the distances here and all the times here. All right, let's start with the one they have given us. They are saying 320 kilometers. And then the time for that is 4 hours. All right, if you remember, we said that the second quantity has to be 1, but here I have 4. So to make it 1, I need to divide. 4 divided by 12 gives me 1. So 4 divided by 4 gives me 1 hour. I do the same with that. Whatever I divide this by, I got to divide this by 2. So 4. 320 divided by 4 is 80. So 80 kilometers. Now I've got my rate. What's my rate? So the rate is 80 kilometers per hour. 80 kilometers per hour. Remember, hour means 1 hour. We had 1 hour here, and we don't need to write 1 hour. So just writing in this form means 1 hour. So 80 kilometers per hour. All right, now what we are going to do, we are going to see what is the link between gradient and also the rate. How gradient and rate are related. And what we are going to find out is that gradient and rate are the same thing. That will be more clear when we do the next example. It says the temperature inside an oven increases from 0 degrees to 180 degrees in 6 minutes. Okay, graph the temperature versus time. So I've got here Cartesian plane where on vertical one I'm putting the temperature and on the horizontal one I'm putting the time. So temperature and time. What they told us was the initial temperature at the start we have 0 degrees, and of course time also is 0. So where both of them are 0, it is here. So that is where both the time and also temperature is 0. So that's the start. And then what happens? Then after 6 minutes, we got 180 degrees. All right, let's make it a bit easier for ourselves by changing this number to 300. Let's say this is 300. All right, so when the time is 6 minutes, the temperature is 300. So that is 300. That is 300. And I have a temperature of, when I have a temperature of 300, the time is 6 minutes. Let's make each of them as 1 second. If we make this as 1 second, 1, 2, 3, minutes, 3, 4, 5, 6, 7, 8. So 1 minute, 2 minutes, 3 minutes, 4 minutes, 5, and so on. Now, time is 0, 0, and time is 0, the temperature is 0, and then we have time 6, and the temperature is 300. So what we do, we graph these results. So 0, 0, and then we have time 6, temperature is 300. That is the temperature. So that is my graph. That is the graph of the change in temperature with time. All right, now we have that. That is the first part of the question. Then what they are asking from us. Then find the gradient of the graph. If you remember, gradient is rise over run. So gradient is equal to rise over run. So that means all right, what is rise, what is run? So rise is how much we go up, and run is how much we go across. Say we go from this point to this point. From the start of the graph to the end of the graph. How much we go across? It is 6. So the run is 6. So run is 6, I put it in the denominator. And how much up we go, that's the rise, which is 300. And 300 divided by 6, remember fraction is dividing. So 300 divided by 6 is 5. So the gradient of that is 5. That is for part 2. We find the gradient of this line. And part 3, find the rate of the change of the temperature with respect to time. All right, now we are finding the rate. So again, I'm going to write two quantities. One is temperature and one is time. So temperature that is time. I'm going to write all the temperatures here, all the times here. What temperature we are talking about? 300. And how long that has taken? 6 minutes. So 6 minutes. So that's the 300 degrees C, and 6 minutes. Okay, that is my second quantity. I got to make it 1. So how do I make 6 1? By dividing by 7. But because I divided this by 6, I got to divide this also by 6. 300 divided by 6 is 50. So 50 degrees centigrade for 1 minute. That is what I wanted. So 50 degrees C per minute. Again, I'm not going to write 1 minute. Per minute means just minute. That is my answer, 50 degree per C. Sorry, when we're dividing that, 300 divided by 6 is 50, not 5. So 300 divided by 6 is 50. All right, now in part 4, they are saying compare the gradient and the rate. All right, that is the rate. That is the gradient. As you can see, they are the same, 50 and 50. So gradient is equal to rate. So that is an important thing to remember, that gradient and rate are the same thing. That is all for this lesson. Thank you for your attention.